Hey guys, welcome back. Houston Math Prep here. In this video, we're going to take a look at the lattice algorithm for whole number multiplication. This algorithm relies only on single-digit multiplication. Because of this, it is often referred to as a low-stress version of the multiplication algorithm. This also is a very visual approach. So let's dive in. Taking a look at the problem 54 times 16. In order to perform lattice multiplication, we need to draw our lattice here. So because we are multiplying a two-digit number with a two-digit number, our lattice needs to have two columns and two rows. Then we want to draw diagonals through each of our boxes. Once we have that built, we want to go ahead and put one of our values at the headings of the columns and one at the sides of the rows. All right, once we've got everything labeled, now we're ready to actually do some multiplication. So to fill in each of these triangles, we're going to first do the multiplication based on what is in that column and that row. So this top left box would be 5 times 1. 5 times 1 is the number 5, but we need two values to fill this in. So we're going to write that as 0, 5. Going one box over, although really you can go in whatever order you want, this next top right box would be 4 times 1. 4 times 1 is 4, so we're going to write that as 0, 4. Completing all of our boxes in the same way, 5 times 6 for our lower left would give us 30, and 4 times 6 for lower right would give us 24. Okay, so now we've done all of our multiplication, and now it's time to get our final answer. To do that, we're going to add up the values in each diagonal. So starting with the ones place, the only thing in that diagonal is a 4, so our ones digit is 4. The next diagonal over will give us our tens place. So 4 plus 2 plus 0 gives us a tens place of 6. For our 100s place, we'll add up the numbers in the next diagonal. So 0 plus 5 plus 3 gives us 8. If we had anything in our next diagonal, we would add that in as our thousands place, but since we don't, our final result for 54 times 16 is 864. All right, notice in this one there was no regrouping. Every diagonal added up to a sum less than 10. Let's take a look at what happens if we do have regrouping and how that's handled in this algorithm. So let's take a look at the problem 186 times 27. Here, because we are including a 3-digit value, our lattice is going to look a little bit different. We need to have 3 columns and 2 rows. Once we have that drawn and all of our diagonals in, we'll go ahead and place 186 at the top of our columns and 27 vertically down our rows. Now we're going to complete each square using the same method as before. So 1 times 2 is 2, so we'll write that in as 0, 2. 8 times 2 is 16, so that will come in as 1, 6. 6 times 2 is 12. 1 times 7 is 7. 8 times 7 is 56. And 6 times 7 is 42. Now that we have all of our boxes and triangles filled in, we repeat the process. We get our digits by adding up the sum of the values in each diagonal. So 2 here is our ones digit. Now moving over to our tens digit, when we add up 6 plus 4 plus 2, we get a sum of 12. So we'll bring the 2 down and carry the 1 up into the next diagonal. Adding up to get our 100s place, we have 7 plus 5 plus 6 plus 1 plus 1 is 20. So we'll bring down the 0 and carry the 2 into the next diagonal. Now we have 2 plus 1 plus 2 is 5. If we had anything in that top diagonal, that would come down to be in our 10,000s place. Since we don't, our final answer here is 5,022. All right, guys, that does it for this video on lattice algorithm for whole number multiplication. To see more like this, keep on watching, and we'll catch you in the next video.